The Brainstarter deals with the basic grasp of the sine function, and it introduces two new vocab terms, period and frequency. So real quick, I'm going to sketch the sine function at the top. Remember, it starts at 0, goes up to 1 at pi over 2, hits 0 again at pi, goes to negative 1 at 3 pi over 2, and then at 2 pi goes back to 0. So, the question is, what's the period, which is the distance of each cycle of sine of x? Well, as we mentioned before, this happens at 2 pi. So the distance of one cycle going from 0 to 2 pi is just 2 pi. Then, it asks what's the frequency, or the number of cycles that happen within 2 pi of that graph. And since we start here, and one cycle happens from 0 to 2 pi, the frequency is simply 1. Now let's review the basic sine and cosine graphs. Last class we dealt with this coefficient out front, the a, in either sine or cosine, and that determines what the amplitude of the function is. And remember, the amplitude tells you how high and how low the function goes. So a big amplitude would go big, or a smaller amplitude would just go like that. It also determines whether or not we reflect over the x-axis. And remember, you reflect over the x-axis if that a value is negative. Today we're going to be looking more specifically at this b value. The b value actually just gives you the frequency, which tells you how many cycles happen between 0 and 2 pi. On the Brainstarter we had a frequency of 1 because the b value is just 1. But today we'll be dealing with other things. If the b value is higher, it means that more cycles happen between 2i. If the b value is lower, like say, I don't know, 1/5, then it'll be a much wider situation. The period is basically how long each cycle is, and all you have to do to find the period is you take 2 pi and then divide it by the absolute value of b. So to recap, if your b value is larger, it's like you take the original sine or cosine graph and kind of squish it and condense it on the left and the right. If the b value is smaller, then you're stretching it out and making it wider. In this example, we're going to graph y equals 2 sine of 1/2 x. And the first thing we're going to do is fill in the amplitude, frequency, and period. The amplitude just comes straight from the a value, which means it's 2. And it's not negative, which means that it doesn't get reflected over the x-axis at all. It just goes up to 2 and down to negative 2. Now the frequency is the b value, 1/2, which means that from 0 to 2 pi, this goes through 1/2 of one full cycle. Now, the period for that, we have to do 2 pi divided by the absolute value of 1/2. The absolute value of 1/2 is just 1/2, and 2 pi divided by 1/2 equals 4 pi, which means a full cycle of this sine will go from 0 to 4 pi. Okay, now let's graph this. So, if we're stretching from 0 to 4 pi, from here all the way out to here, which is twice as long as between 0 and 2 pi, essentially we're going to hit these milestones, the mins, the max, the zeros, at twice as much. So you see how we have a maximum at pi over 2 here on the original one? That maximum is actually going to stretch out to pi, and since the amplitude's 2, it's going to be up here. Now we go over another pi, we'll be back down to 0, go over a further pi, 3 pi, and we'll be at negative 2. And we can just continue this pattern. And now you just connect the points using a smooth curve. And now you have 1.5 cycles of 2 sine of 1/2 x.